Hi everyone, we are in the skinny packet and we are starting our next chapter, chapter 8, and this is the big chapter. It's this chapter and the rest of the semester that's going to be really big. One chapter just goes into the other, and then all of this goes into Algebra 2, so it's really important that we stay on top of this and that if you are feeling lost that you speak up sooner rather than later. So chapter 8, we are venturing into our final shape of quadratic functions. And so in your skinny packet, I am on page 28, and we're just going to start to look at the 3 different forms of quadratic functions. And this whole chapter will just be working, how do you go from one form to the other form. So 2 of the forms you're already familiar with. One is, so let me back up. A quadratic is a polynomial with a degree of 2. So again, just back from our last chapter, that means the highest exponent that you're going to see is going to be a number 2. And then they can be written in 3 different forms. So the first form you're already familiar with. That's standard form. And so now what we're going to do is we're going to start to throw some letters in there. So every function we've worked with so far has always had x and y. And then these other letters, a, b, and c, take on numbers. So this is in standard form because it's the highest exponent first, then the next until we get to the constant that's at the end. And you're going to notice that the degree is a 2. So that's what we are referring to when we say a degree of 2. The next form that you are familiar with is factored form, because in chapter 7 we talked about terms and we talked about factors. So terms are separated by addition, subtraction, and factors are separated by multiplication, because you need one factor to another to get what you started with. Just like factors of 32 might be 8 and 4, because you need 4 and 8 to get back to 32, and they're separated by multiplication. So again, just like before, you're going to see x and y, and then there are these other letters, a, p, and q, that become numbers. So factored form. So x minus 2 is a factor, and 2x plus 3 is a factor. The new form is called vertex form. And so again, look for x and y, and a and h and k become other numbers. One thing that's important to notice, again, is that they all have a degree of 2. And even though you don't see it, if this factor were to distribute into this factor, or for lack of better words, if this neighbor was to meet this neighbor, x and 2x, you would start out with 2x squared. So there is a degree of 2, but because it's in factored form, you just don't notice that. All right? So what we want to do is just make sure we understand the 3 forms. So again, what's the form we should be very familiar with is standard form. Standard form has no parentheses. It's all addition, subtraction, and that's going to be this one. And I'm just going to abbreviate with SF. Again, the next form that you should be really familiar with are the factors. So x minus 3 is a factor, x plus 1 is a factor. So this is what we're going to call FF for factored form. And then finally, our last form then is called vertex form. So the big difference, is that this has 2 factors and you don't notice the squared, and vertex form, you notice the squared. All right? So sometimes people confuse these because they both have parentheses. All right, so just kind of summing up what's here. So each form is useful, but in different ways. And when we start to graph our quadratic forms, vertex form, this one, is the preferred form. When solving quadratics, then factored form is our preferred one. Now, it's not that standard form isn't preferred, but it's not as great as, let's say, these 2 forms. But they're all good, and what we're going to be practicing in this chapter is how do you go from one form to the other form. So the first thing we're going to talk about is how do you go from standard form to factored form. And to do that, we're going to be looking at factoring. And so there are many steps of factoring. In Algebra 1, you learn about the first set, and then in Algebra 2, you start to learn about the next types of factoring. So the first step of factoring is called the greatest common factor. And what you do is you look at each term and you look for the largest integer, so the largest regular sized number that can come out or divide out or factor out, and then you look for the largest amount of variables that can go out. So just pause 1 second. So it says the lowest degree of each variable because what we're trying to do is take out as many x's from each term as possible. All right, so when I look here, the first thing I notice is that both terms, 9 and 45, can be divisible by 9. So that will become a GCF. Then I look at each term and see, are there any x's that could come out or divide out or factor out of each term? And that's not possible because this term has an x, but this one doesn't. So we are left with, when I divide x out, or I'm sorry, when I divide 9 out, I'm left with an x from here and a 5 from here. So essentially what we're doing is we're finding who are the neighbors that met to get to 9x plus 45. When I distribute this back in, I get 9x. When I distribute that back in, I get 45. So let's take a look at this one. What is my greatest common factor? So the first thing is I focus on the regular sized numbers. In this case, they're all coefficients. And I notice the biggest number I can divide into all of those is a 3. And then what I look for is how many x's can I take out from each one. So I'm just going to expand these out so you can see that this has 3 x's, this has 2 x's, and this has 1 x. So I need to take the same amount of x's, divide out, factor out the same amount of x's from each term. So since this term only has 1 x, that's as many as I can take out from all of them. So what I'm going to do is factor or divide out one of these x's, and when that happens, this one goes away, one of these goes away, and one of these goes away. So what this is doing is when you factor, and this is one of those exponent rules that we talked about in chapter 7, is when you factor out an x, well I won't need the 3 there, that you subtract the exponents. Because what's happening here is there are 3 x's in the numerator, 1 x in the denominator, and when they cancel out, you're left with 2. So essentially, we're just subtracting the exponents out. So I'm going to factor out a 3x. And again, when we factor, we are seeing what neighbor meets what neighbor to make this. So if you divide this by 3x, you're still left with x squared, because when this distributes back in, you get 3x cubed. Here comes the minus sign. If I divide this by 3x, then I'm left with 3x. And again, just showing you what happens. Factor out means you're dividing out. So 9 divided by 3 is 3. This means I have 2 x's in the numerator, 1 x in the denominator. They can cancel out, and I'm left with 1 x, and that's why we get that 3x there. And when I divide this by 3x, so again, just 27x, divided by 3x, 27, divided by 3 is 9. These x's cancel out, so we're just left with 9. So factoring is just, in this case, we're looking at it as division. So if this neighbor meets this neighbor, we get 3x cubed. When 3x meets 3x, we get the 9x squared, and when 3x meets 9, we get the 27x. Next example. So here I notice this has a coefficient and this doesn't. So there's no coefficient that I will factor out. But what I do see is I can factor an x out of each one, because this has 2 x's and there's 1 x. So I'm going to factor or divide out an x squared. And again, when you take x squared and you factor or divide an x, you're just saying 2 x's in the top, 1 in the bottom, these cancel out, and you just get to x. Or you're just subtracting the exponents. So I'll be left with an x here, there's the plus sign, and who did x meet to get 2x? That would have been a 2. So you're going to see I'm going to kind of explain this many different ways, trying to figure out what works best. All right, the next two are special because when I look at our leading term, it's negative. And our goal is when we get into more factoring is we don't want the leading term to be negative. So in this case, I will factor that negative out. So when I go for my GCF, I will factor out a -7, and then I will factor an x from each term. So again, when we're factoring, we're just asking, who did -7x meet to make this? And that would have been a -1. Sorry, not a -1. I got to get my white out. Time out. Just a 1 if you want to put the 1. But you don't have to put the 1. So I'll just leave it as x. When this neighbor meets this neighbor, we get this. And who did -7x meet to get 21? That would have been a -3. All right, in this case, again, if your leading term is negative, you want to factor that negative out. So I will be factoring out a negative, and the number that divides into all of these, the biggest number is going to be 5. And then there's 3 x's, 2 x's, and an x, so I can take at least 1 x from each term. And now, who did -5x meet to make this? Well, it met 3 for the -15 and 2 more x's to get x cubed. And then, who did -5 meet to get this? Well, from -5 to -25 is a +5. And from 1x to get to 2 x's, I need another x there. And then who did -5x meet to get 5x? That would have been a -1. So notice sometimes I write minus, sometimes I write plus negative, but that is a GCF. Once you factor a GCF, from there we learn about what's called completely factoring. So before we get into completely factoring, we're going to look at just the basics of it. So once the greatest common factor is factored out, there are 2 ways so that the quadratic function ends in completely factored form. If the quadratic has 2 terms, then that's called a difference of squares. If the quadratic has 3 terms, then what we're going to do is something called the grouping method.